Hi, Precal. I'm back to finish the rest of the notes here, and we are on number 5. So we have negative sine squared x over cosine x plus secant x equals negative 1/2. So I'm going to work on the secant x first. So I have negative sine squared x over cosine x plus 1 over cosine x equals negative 1/2. Well, I need to put this together to make one term because I can't set them separately equal to a half or anything like that. So I need to try to simplify this. Well, I already have a common denominator here and here. So I'm just going to put the numerators together, which is negative sine squared x plus 1 over cosine x equals negative 1/2. And I could rewrite this. I don't have to, but if this helps you visualize it better, negative sine squared x plus 1 is the same as 1 minus sine squared x over cosine x. Now I can look at my Pythagoreans. 1 minus sine squared, if I go up here, if I were to subtract the sine squared over, it would be 1 minus sine squared, and that's equal to cosine squared. So I'm going to replace the numerator with cosine squared x over cosine x, and that reduces to cosine x equals negative 1/2. I'm going to come over here and think about my unit circle. Cosine is negative 1/2 here and here. Cosine is negative in quadrants 2 and 3, and it's these two coordinates, which are 2 pi over 3 plus 2 pi k, because it said all, and then 4 pi over 3 plus 2 pi k. Okay, and that's that one. All right. Now, let's see what we got here. Oh, no identities needed, just factor. So factoring can be tricky when you have trig. So what I'm going to do is come over here and choose a letter. And just for lack of confusion, I'm going to choose the letter A instead of X. And A is going to be the same thing as cosine X. So I am making a substitution. I'm going to replace all of the cosines with A. So this will become A squared minus 4A plus 3 equals 0. So then we're just going to factor these. So that's going to factor to A minus 3 and A minus 1, because that multiplies to positive 3 and adds up to 4. And then I can set each factor equal to 0 separately. You can only set the factors if it's 0. And then replace it back with cosine x. So cosine x minus 3 equals 0. So cosine x equals 3. Well, that never happens. Cosine can't be bigger than 1. And then here cosine x minus 1 equals 0. So cosine x equals 1. And where does cosine equal 1? It's only here, which you can write a bunch of different ways. You could say 0 plus 2 pi k, or 2 pi plus 2 pi k, or the shortest way would just be 2 pi k. Because if k was 0, you would get 0. If k is 1, you get 2 pi. If k is negative 1, you get negative 2 pi, and so forth. Okay, only 2 more problems. Here we go to simplifying again. So this is sine x times 1 over sine x, and that's over 1, minus sine squared x, and where does that equal? 1. These cancel, so we get 1 minus sine squared x equals 1. Well, we know that's cosine squared x. Okay, this one's kind of different because we have a cosine squared. Well, in order to solve that, you have to square root both sides. And when you introduce a square root, you have to put the plus or minus. The square root of cosine squared is just cosine, but it's going to equal plus or minus, and the square root of 1 is 1. So I need to think where cosine is positive or negative 1. Cosine is positive 1 here, because this ordered pair is 1, 0. And cosine is negative 1 here, because this ordered pair is negative 1, 0. So we will say that x equals, again, a lot of different ways to write this. The shortest way to write it is pi k. That's not the only way, but if k is 0, you would get this point. If k is 1, you would get this point. If it was 2, you'd go back around, and you would hit all of those points every pi apart. Okay? All right, last question, another factoring one. So again, let's let a equal this time sine x. Okay, then we'll rewrite this as 2a squared minus a minus 1. Now, this is a factor by grouping, so I need to come over here and multiply 2 times the negative 1, which is a negative 2. What adds to negative 2, that there's an understood 1 in front of this. So what adds to negative 2, multiplies to negative 2, excuse me, and adds to negative 1, and that would be negative 2 and positive 1. When I multiply them, I get negative 2, check, and when I add them, I get negative 1. So I'm going to split the middle. So you split this up, and it's 2a squared minus 2a plus 1a minus 1 equals 0. You group the first two and the second two, pull out a 2a, and you get a minus 1. Here, the only thing they have in common is 1. So go ahead and write the 1, and then that's going to be a minus 1. And then the a minus 1's match, so that's a common factor, and you're left with this one and this one, 2a plus 1. You set each factor equal to 0. And then we can go back at any time and put sign back in. So let's do that now. Sine x minus 1 equals 0. So we want to know where sine x equals 1. And 2 sine x plus 1 equals 0. So 2 sine x equals negative 1. And sine x equals negative 1/2. Okay, so where is sine equal to 1? That's going to be there. So this answer is pi over 2 plus 2 pi k for that part. And then also, I'll go back to the same unit circle. Where is sine negative 1/2? That's here and here. Okay, because those ordered pairs have a y value of negative 1/2. So that is 7 pi over 6 plus 2 pi k. And then 11 pi over 6 plus 2 pi k. So there's two different parts, but all of that is the answer, okay? That's all one big answer. All right. Please feel free to add to the discussion if you have any questions. I'm happy to help. I can make you another video. We can figure it out, okay? Hope you're doing well. Bye.